Good. Today we will complete strings, lists, and tuples. We will learn them side by side together, so you know which data structure or type should be used when. Good. Mm. Okay. See, string is a data type, right? And lists and tuples are data structures. So the name string is a very generic term. It is nothing but a characters. Set of character is called a string. In Python, we can create a string just by opening double quotes or a single quotes. I am a string. This is a string. Even this is also a string. I am a string. In Python, quotes doesn't matter. Single or double quotes, they behave the same. I am a string. To prove that, let me compare, equate whether A is equal to B or not. You should be already familiar with this, right? Comparison operator. Mhm. Just give me a minute. Yeah, see. Here, I stored I am a string variable in single quotes in the variable A and using the same string in a double quotes in the variable B and tried to check whether both of them are same or not. And the result is true since Python doesn't care about the type of quotes you use, but you should be careful that you should not start with a single quote and then end with a double quote. This is illegal. See, this is not ideal. Starting and ending quote should be the same. They can either be a single or a double. And see, you might ask how many characters can this string contain and what characters can this string contain. A string can contain any number of characters. Theoretically, it can go to infinity and it can contain any character. Anything that you could type with a keyboard could be placed inside a string, except with one exception. You should never use a backslash. If you really want to represent a black backslash in a string, you should use double slashes. Let me try to print this. Print B. Okay. Here, even though you have written double slash, you only get a single slash. See, In Python, you should never use a single slash in a string. If you really want to represent a slash, you should write two slashes. I will explain why this is the case later. And now a string can contain any number of characters and any characters except a backslash. And if you really wanted to use a represent a slash in a string, you should write double slashes instead of a single one. And you might ask, what if, see, this is how the actual string, this is the actual string, right? And when I try to print it, this is how it prints. But what if you want to represent a string that spans multiple lines, like this message. We want to greet an newly signed up user. Hi John, how are you? You can't just write it in a single string, right? What if I wanted to represent this in a multiple lines? Something like, see, what if I want to write hi John in one line and how are you in another line? There are two ways to do it. You can either use escape sequences or you can either use multi-line strings. Here is multi-line. Escape sequence is nothing but slash and n. The moment you write slash and n, Python interprets this as John, hi John. It will understand hi John, and slash n is nothing but go to the new line. Instructing Python to go to the new line. Now, when I try to print this, see, hi John, how are you? Oh, we have an extra space because we have an extra space in here. See? You cannot use slashes inside this string because exactly this reason. Anything followed by a single slash will become an escape sequence. So you should never use a single slash. If you want to represent a new line, you should write slash n. If you want to represent a tab, let's say tab is nothing but four spaces, right? If you want to represent a tab rather than giving four spaces, you can write slash and t. All you have to remember is you cannot use slashes, backslashes, especially inside these strings. If you want to represent a backslash, you should write two slashes. And if you want to write represent a tab or multi-line or break a string into different lines, you should use slash n and slash t. This is one way to write multi-line strings, and the other way is using triple quotes. Just like how we can use single double quotes or single quote single quotes or double quotes, we can use triple single quotes or single double quotes. Hi John, how are you? Python automatically preserves the formatting. Here, any spaces you give or any new lines you enter into this text are preserved. Something like this. Let me print the message. See, the formatting, the extra spaces, the line breaks, and the tabs, everything written inside an triple quotes are preserved. You can do the same with single quotes too. Here I use double quotes, right? You can even do this with. Mm, See, it doesn't make any difference. The advantage of using a triple, double, or triple single quotes is that inside these quotes we can write another quotes again like this, and this will not lead cause any errors. This is far too advanced. Just keep in mind that if you want to write a string, either use single or double quotes, and if you want line breaks, you can either use a triple quotes to do it, and it will preserve the formatting, or you can use escape sequences /n and /t inside a string. This is how we can create a string, and the strings can be created directly used in our expressions like this. Here I am not storing John in any variable, but I am directly using in any expression, right? You can either use it like directly like this, or you can store it in a variable and reuse it later, just like any other data type. Now the list, how can we string is equal to string. This is how we can create a string. Now, just like how string is an mm, consists of characters, list is a list of elements. An element can be anything, any data type or any data structure in Python. Text list is equal to, we know there are integer, a float, a string, a boolean, and let me put another list inside this. See, I can even write a tuple here too. List is a list of elements, and a element can be any data type, any data structure, anything that can be written in Python can be put into a list. This is how we create a list. List is created using solid brackets, and data is written inside the list separated by commas. Clear? And let me copy this down. And text tuple. See, a tuple is list's brother. It is exactly identical to a list. The only difference is it is immutable. We will go over immutability later. See, now, does any of you have any doubts regarding how we can create a string, a list, or a tuple? No, right? Good. Now, since we have seen how we created a string, list, tuple, now what we will do is understand. Once a string has been created, we need to access the data. Let's say we stored some students' information in a list, and later in our code, we want to use the information stored in a string or list or a tuple. Then how can we access the information stored? Data inside string lists and tuples can be accessed using something called indexing. Indexing is nothing but accessing data by position. Anything you store inside a string or a list or a tuple is stored based on position. Like here I wrote string, right? Even in memory, it is stored sequentially, that is one after another. So when I want to retrieve data later, I need to mention the position where it is stored, and then Python can retrieve it for me. We can also change its name to text string, text list, and text tuple, right? Here, the name of the variable can be anything. I'm just naming it test underscore string to make it easier to understand. Let me ask, let's say I wanted to retrieve the fourth character in a string. This is how I do it. We should write the variable name first or the string data type first, and then open bracket, solid brackets, and then write the index of the data that we would like to index is nothing but position of the element that we would like to retrieve. The same thing can be done for list and tuple too. See, if you see the fourth element, what is the fourth element in the list? 0, 1, 2, 3, 4. The fourth element in the list is an another list, right? A nested list. So it returned 1, 2, 3. We can either capture this returned data into a new variable or use it in our expressions directly. Here I am capturing it in a variable called var, and we can use this var later in our expressions. uh, one in var, something like this. Indexing can also be done for tuple, and it is exactly the same. Now, how are the values inside the list? How are the elements inside a characters and list and tuple are numbered? Numbering or indexing of positions or in Python always start from zero. So in a list, this value 1 has a position 0. This value 1.0 has a position 1. This value string has position 2. We should 0, 1, 2, and so on n. Where what is n? You might ask, and n is nothing but the total number of elements inside a string or list or a tuple. N minus 1. If you count, they will be n elements. So the final last index, last position of the last element in a list or a string or a tuple can only be accessed by not by the length but length minus 1. Let's say here the list contains 5 elements, right? 1, 2, 3, 4, 5. If you write something like test list 5, it will raise an error because wait, 1, 2, 3, 4, 5. Yeah, there are 6 elements in here. 6. See, it will raise an error because it is counting from 0 to 5 and you are trying to write 6. You might justify that since 6 is the length of the list or a string or a tuple, I am writing 6. So, which is false. If the length is n or if the length is 10, the last element should be accessed using n minus 1 or 10 minus 1. Clear? Is the positive indexing clear or does anyone have any doubts? Good. Now, positive indexes are easy to understand, but there is also a negative indexing too. Just like how the elements in a string list are numbered from 0 to 1, they are numbered in the opposite direction too. Minus n, minus n, minus 1. They start from minus 1, minus 2. Uh, from the starting, if you want to know the position of a element from the starting, we should start from 0. But if we want to know the position of a element from the ending, we count from the last element is has a position of minus 1. Last but one element will have a position of minus 2. And the starting element from the reverse order will have a position of minus n. This might be confusing because we start from 0 and end with n minus 1. But in case of negative indexing, we start with minus n and end with minus 1. So let me access. This can be pretty useful when, let's say, we wanted to retrieve the last element from a string, but we don't know the length of the string. In such cases, all we have to do is we know that the last element index will be minus 1 from negative side, right? So all I can do is minus 1 and it will return the last character in the string, which is G. See, here the variable has a string. So the last character is G. And the same is true for lists and tuples. Elements in strings, list, and tuples are numbered from starting to ending using 0 to n minus 1, or also numbered from back to front, ending to start using minus from minus n to minus 1 to minus n. Is the positive and negative indexing clear? Good. Now here is the most confusing part. We will go over slicing. Now we learned how to create a string list and a tuple. We learned how to access a single element from a string list and a tuple, either using positive index or either using negative index. Now we will try to learn how to get multiple elements from string list or a tuple at once. Like what if we wanted to find all the data from the position 2 to position 5? This is a real world situation, right? Let's say we stored some student names inside a list and we wanted to only get a set of students from position 2 to position 5, something like that. And then we can't access every position like this, right? Like text list, we can't get this is impossible, impractical. So we need a way to get multiple elements from a string list or a tuple at once. And the process of retrieving multiple elements from a string tuple or a list is called slicing. Positive indexes, negative indexes. List. Yes. Yes, slicing has this format. We mention the list this here. Take a look at this. Slicing will have this format. We will mention the data or the variable holding the string list or tuple. Then we will mention the starting position that we want to get. Then the ending position we want to get, and then the step. Ignore this step for now. I will explain it later. Let me try to slice our string. Let's say. To make it easy, let me write something in GH. I will try to retrieve the elements from the position 2 to position 5, let's say. Now I should write the starting position 2 and the ending position 5. Here 2 doesn't mean 1, 2. It means 0, 1 and 2. So from C to D, 2, 3, 4, 5, F. So you will expect that I need to get character from C to F, right? C D E F, but C. But you will only get until C, D, and E. You will only get position 2, position 3, and position 4. You won't get position 5 because this is how Python works. When you try to slice, when you mention the starting and the ending position, Python will ignore the ending position. It will not give us back the data at the ending position. It will only give us up to one element before the ending. Here is the easy way to understand. Here I am trying to slice from 2 to 5, right? What is the difference? The difference is 3, right? See here. The Python will only return the number of elements the same as the difference between starting and ending position. So this is designed in that way for developer convenience. But when we start out learning Python, this will be quite confusing because you might think I wrote 2 and 5 and we should get everything from position 2, 3, 4, and 5. Just remember that the ending index won't be written. We will only get the index before that. So if S is our starting and E is our ending position, we will only get S, S plus 1, and so on up to E minus 1 and not E. Is this thing clear? Is slicing from a point A to point B clear?
Yes.
Good. Now here is the tricky part. What if I want to retrieve from point A to point B, not directly but in steps? Like I don't want S plus 1, but I want S plus 2. I don't want S plus 3, but I want S plus. This is a regular path, right? when we write escape m, enter. If we try to slice a list from S to E, this is what we expect. We expect to get S plus 1, S plus 2, and until E minus 1. But what if we want to get S plus 1 plus D, S plus 2 plus D, and so on? This is quite confusing. In such cases, we will just write colon D. This means that don't fetch every element, but only fetch the second element. Jump two steps at once. Don't jump. Imagine A, B, C, D, E, F is is a footpath, and you can jump from one element to another. In case of regular slicing, it will jump from one step to another step and will fetch all the values. But when you mention a difference as your third value here, colon and D, what it will do is instead of jumping one step, it will jump that many number of steps and will only retrieve that value. Here, test string is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9. Here is a string. I will try to slice from second element to eighth element. I didn't mention any step. Here I will slice this same string from second element to eighth element with a step of 2. Here I will try to slice the same string with a step of 3. Here, by default, if you don't, you need not mention colon 1, but it will assume automatically step size is 1. See, here I am slicing from 2 to 8, right? Here I got 2, 3, 4, 5, and 6. 2, 3, 4, 5, and 6. But take a look at this line. Here I am trying to slice from 2 to 8, but with steps of 2. So it first stopped at 2, then it directly went, it jumped 2 step, one step to 3, the next step to 4. And you will see 4 in here. And then from 4, it jumped to 5 and jumped to 6 because we made this step is equal to 2. And so we got 6. In case of when the step size is 3, 2. Now 3 steps from 2 is 3, 4, and 5. So we got 5. Now 3 steps from 5 is 5, 6, 6, 7, and 8. But 8 is the last element we mentioned in our range, right? So it won't return the 8. If it had been 7, it would have returned 7. Is regular slicing and slicing with step clear? Don't be shy to ask any doubts because this can even trip experienced developers. So if you don't understand anything, just you can ask me. Good. Now, what we learned was creating a string using single double quotes, creating a list using solid brackets, and creating a tuple using parentheses, and accessing single data from an element using index. Index can be positive from 0 to n minus 1 or negative from minus 1 to minus n, counting from the back. Negative indexes can be pretty useful to query the last element in a string or a tuple. So when we don't know the length of the string or tuple. Let's say we don't know the length of the string and we want to retrieve the last element. There is no way to retrieve it. We should calculate the length first, then use that to retrieve the element. Even in this will give me an error, just like I told length minus 1. Here you understand why I wrote n minus 1, right? If the length is, if the string contains n elements, then the last index should be n minus 1 and not n. Clear, right? Then we went over regular slicing, mentioned the starting and the ending position, and it will retrieve all the elements falling in between those numbers except the last index. It won't return the element at the ending position. And then we went over slicing with step. This slicing with step is rarely used, but just remember that something like this exists. And when you face a problem that could be solved by this, you can just Google it up and check how this thing works. And now here is the another tricky part. Just during slicing, you just mentioned positive indexes for slicing, right? You might ask, can I use a negative index for slicing? Yes, you can absolutely do this. And when you try to mix up positive and negative indexes, print text string. This is how you should interpret this. Since I am asking to slice from the third position to the minus third position, right? Imagine a solid line, move 3 steps forward from the starting and walk 3 steps backwards from the end of the line. This is how you get the re- sliced value. See here 0, 1, 2, 3, 4, 5, and 9, right? Since the starting position is 3, 0, 1, 2, 3. I started walking from the left side from 3, 3, 4. Start walking from 3. No, just remember that you stood at 3 and now the final index is minus 3, right? Since this is a negative index, we should walk from back 8, 9, and 7. Minus 1, minus 2, and minus 3. Here 7 is minus 3 and positive 3 is 3. So 3, 4, 5, 6, and 7. But false because you slicing will not retrieve the final element, right? So minus 3 will not be given and we will only get 3, 4, 5, and 6. Imagine walking from starting and walking from the back and retrieving only the part that overlaps. And you might ask, what if I write an index that is out of the list while slicing? Let's say minus 66. Here, minus 66 doesn't exist, right? And even let me write 33. Even 33 also doesn't exist. When you slice, if you mention indexes that doesn't exist, it will return an empty list. In case of a string, it will return empty string. In case of a tuple and a list, they will return empty tuple and empty lists. If there are no elements to slice or if no elements fall in the mentioned indexes, I mean indexes doesn't exist in the actual list, you will get an empty string or an empty list or an empty tuple depending on what you are slicing. But be careful. This only applies to slicing. When slicing, you can mention indexes that doesn't exist in the value. But in case of indexing, I mean, when you are trying to retrieve a single value, be careful. If the index doesn't exist, you will get an error. Clear? Good. Now we created strings, tuples, and list. We accessed single elements from strings, tuples, and list. We retrieved multiple elements from strings, tuples, and list. The sliced value can either be stored in a variable and reused again or directly used in expressions. We went over positive indexes and negative indexes. We also covered slicing with step, slicing with positive and negative combined. Now you might ask if I have already created a list, right? What if I wanted to replace a string or a list or a tuple? We have already created those. But what if I want to selectively replace a value? Let's say we want to replace a value at a fourth position with something else. You, we have learned how to slice, how to retrieve the value at the fourth position. But what if I wanted to replace the value at the fourth position? Let me print the text string, text string. Let me print the value at the third position. Text string. All we have to do is just mention that the third position in the string should take a new value of 44. I won't execute it. This will raise an error. Control A, Control C. Print test list. See, when I execute this cell, it will raise an error, but when I execute this cell, it won't raise an error. And you should tell me why. When I try to access the third value in the element at number 3 index and replace it with a value called 444, it raised an error. But when I did the same with a list, it didn't raise an error. Here is the original list. Here is the list after print after modifying. Let me print it again. See, this is the original list. Here I tried to look at what element existed at position 3, index 3. This is the value that existed here. I replaced it with 444 and then tried to print the modified list. And here is the modified list value 0, 1, 2, and 3. Here it got replaced with 444, right? No. 1, 2, 3, 4. Why did I get? Yes, this is already 444. Test list. A, B, C, D, E. See, is this thing clear? Here I just try to access the third index and try to replace it with a 444 value, and I tried printing the list again. Here it actually got altered, right? I successfully selectively replaced a value inside a list with another value. But when I tried to do this with the string, it failed. And if you and the sole reason why this happened is string is immutable. You can only create it, you can access it, but you cannot replace its data directly. Here, what we are practically doing is we are asking Python to replace the third character in our string with this value. This is the reason why it fails. String, as I told earlier, is a data type, and data types are immutable. You can create them, access them, but you cannot modify them once they are created. But list here is an data structure and an mutable data structure too. Let me try to do this with the tuple, and this will also fail. I am trying to print the tuple, access the third value in the tuple, replace the third value in the tuple. See, we will get an error too, because even though tuple is an data structure, it is an immutable data structure. So we can only create it. Once created, we can only access the data from it, but we cannot replace or mutate the original data. Is the immutability clear? Immutability part clear? Okay. Strings and tuples and lists can be created, data can also be accessed, but we can selectively cannot rewrite or access an element from the string and replace it with a new value. And the same goes for the tuples too. But we can do this in lists. Wait, why? Yeah. This is how we overwrite a value inside a list, and this is not possible for strings and tuples. Now, here is an advanced version of it. What if we wanted to overwrite a range of values, not just a single value? but multiple values from a list. Let me delete this. Yes, here A, B, C, D, E, right? What if I wanted to replace everything from B to D with new values? All you have to do is slice. Sorry about that. All you have to do is you need to first slice the values you want to replace. I want to replace from B to D, right? The index of B is 0 and 1, and the index of D is 0, 1, 2, and 3. So since I also want to replace D, I will write 4 plus 1. Now here I want to replace three values, right? So I will try to give three new values too. Look at what happens. Here the sliced value got overwritten by the new values I gave. Here make sure that the length of the sliced value is equal to the new list you are assigning, the length of the new list, new values you are assigning to this sliced portion. Here there is an you can even make this smaller or larger, but this will only confuse you. This is a slightly advanced part. For now, just know that the length of the sliced part should be equal to the length of the list, length of the new elements you are trying to assign. If you mismatch them, they will behave a bit weirdly and it is harder to understand. You can take a look at this once you have progressed in your Python journey. Clear. We have created them. We have accessed data, single data from them. We overwrote single data. We accessed a range of values from them. We overwrote a range of values from them, from strings, lists, and tuples. Now, what is left? Yes. From here on out, we will discuss the methods on strings, lists, and tuples differently. Methods are nothing but the functions built that are pre-built by Python on strings, lists, and tuples. Let's say we had a text, we have a name, right? Let me try to write let here is a name. This is just a string, right? Now, what if Python by default provides us with a few functions on the strings, inbuilt functionality. There is no other way, but we should try to learn them. We can forget the names, but we should remember that such functionality exists. Wait, yes. Here are the most frequently used and most important functions. String dot upper will convert all the characters in a string into an uppercase. String dot lower will convert all of them into a lowercase, and string dot title. And remember, any method on the string will return a new string. It will not mutate the original string. Let's say here I wrote name dot upper, right? And tried to print name. It will not get affected because strings being immutable, all the methods on the string will return a copy and transform them and return that copy and not will not affect the original value. If we want to if we want to persist the transformed value, we should overwrite it like this or either capture it in a new variable. I am stressing this out because in lists there are multiple types of method. In list there is a method that will directly affect the data. For example, names. Here is names. Warm Charlie. Names dot sort. Here I am just asking the Python to sort the names. And let me try to print the names. See? Oh, they are already sorted, right? Let me reverse, equal to. See here, this method on the list is updating the original list, the original data. But here, the method on the string will not update the original data. You have to capture it in a new variable or rewrite it on the same variable. This is because string is immutable and all the methods on the string are will return a copy, will return the transformed version. But methods on the list can either return a transformed version or affect the original data. We will discuss about this in great detail in list methods. But just know that in case of strings, everything will return a copy and you should capture it in a variable. And do not assume that the original data is got affected, so I will use the same variable again. Good. Here, I think these are very easy to remember. The dot upper, dot lower, dot title. Title, nothing but will only the first characters after the spaces. See, the first character and the first character after the space. It will only convert them into an uppercase. And this is pretty useful while displaying usernames because we generally accept usernames in all lower or all caps. So in order to display it conveniently, we will use title to make it easy to read. Let's say if I, this looks ugly, right? If I try to see, this looks ugly and the title looks clean. And the capitalize is nothing but it will only capitalize the first word in the string. Right. See, it will only capitalize the first character in the string. That's it. And title, but title will capitalize any starting character and any character after spaces. Swap case will switch as the name suggests. It will switch case upper into lower and lower characters into upper. Caseful. These are advanced. You can ignore it. Strip, these are important. Strip, L strip, and R strip. Strip is nothing but remove spaces from the starting and ending of the string. Here, let's say I have multiple spaces in the starting and multiple spaces in the ending. It will remove spaces from the both sides of the string. And this is also extremely useful because while designing web interfaces, we generally accept usernames, right? And it is users often misspell their names. They add additional spaces to the starting of the string and ending of the strings too. So we use strip to remove additional spaces before storing them. Lstrip is similar to strip, but it will only strip spaces from the left side. That means starting. R strip will only strip the spaces from the ending. See, it only removed spaces from after E, but it didn't touch the spaces before A. So we are getting an four spaces in here when I try to print it. Yeah, is upper, lower, title, and strip clear? Good. Now the find and index can be used to determine whether an substring or a set of characters exist inside another character. Let's say I want to find whether A is in name. All I have to do is name dot find A. I want to find whether A is in the string name or not. It will return the if the A exists in the string, it will return the position of that character. 0, 1, I think it should be 4. If it doesn't find the character inside the string, it will return -1. And depending on this, we can make our decisions. If if find greater than or equal to 0, print character is find not equal to -1. What this means is character exists, else doesn't exist. See, the find can also be no. can also be used with multiple character. Here I am just checking whether this a single character is in a string, right? But it can be used to either check substrings too. Let me check whether LS exists in the string continuously, not scattered, like A exists, then L exists somewhere else, I exists somewhere, not like that. I am checking whether LS as a continuous string exists in another string. See, actually it exists. But now if I try to check whether cat exists, CAT, not KT, doesn't exist, because if find doesn't find the substring inside the string, it will return -1. And here we framed our condition that if it is equal to -1, print this. The index is exactly the same as the find, except in one case. If index doesn't find the substring, it will raise an error. Here I am trying to check whether cat is in the string, it will raise an error because it doesn't exist, right? But if it does exist, it will return an the index. Just like I am checking whether Alice is in Alice Kate string or not. It is returning me that the value is 4. What it means is your substring exists in the actual string and starts at the position 4. Like here 0, 1, 2, 3, 4. No. 1, 2. 0, 1, 2, 3, 4. And it will start at 4. Is index and find clear? Good. And the count is exactly as it sounds. It will just count whether a character is a how many number of times a substring exists in another string. It will return the number. If it doesn't exist, it will return 0. I am trying to count how many times Alice is in Alice Kate. See, 1. But if I have, let me, Alice, Alice, Alice. See, here it will return 3. Exactly as it sounds. And the replace is also
Can you give single character in that?
where? Yeah, of course. See, you should have asked this question when I wrote a single character and didn't explain multiple characters. Here, I just wrote multiple characters, right? If something supports multiple characters, it means it will support a single character. See, here it is counting the number of times A exists in this string, and it is 4 here one time, two time, third time, and here fourth time in KT. And the replace will replace an substring inside a string with the new value we give, like name dot. I try to print name. No. Let's get replace. I am asking it to replace Alice with Charlie. See, it replaced all the occurrences of Alice with this new character. Here, this can be a single character too. If I wanted to replace ES with double Cs, we can even do this. This looks ugly, but practically we are just replacing A with double C. You can even write a single C too. It doesn't matter. The concept is that whether to search for a single character or search for a substring. Substring is nothing but a few characters that occur continuously in another string is called a substring. Here we can find whether a substring is in another string. We can find its position. We can replace it with a new value. We can count the number of time it occurs inside the string. And the split is very useful. Here the
Tarun, so
yeah.
if we use finder, if we have multiple, yeah. So for finder, if we have multiple characters, like duplicates.
Yes.
Like if A is repeating 3-4 times, then
Yes.
if we want to find the exact like what we required, then how you will find out for
Yeah.
by
See,
using find?
I skip few things so you guys won't get confused. When a character or a substring is repeated multiple times inside a string and you try to find it, it will only retrieve the first occurrence. It will ignore the next of the occurrences.
Mm-hmm.
Your question is, I need to retrieve exact version, right? In such cases, you need not even find. You already know that a substring already exists in another string, right?
Yeah.
What you are trying to ask is Alice, Kate, John, Bob dot find. You are asking me if I want to find Alice. Here the problem is whether Alice doesn't exist here or not. If it exists multiple times, that is a whole different situation. In such case, what you should be doing is counting them. Uh, Students, let's say this is a student. The role of find is to find whether something exists or not. It's not whether to find whether where it exactly exists. It will return the index, but multiple duplicates may exist. In such cases, you should have first done this. Students dot count ls. Then, if a count is greater than, you should first know the count. And depending on this value, you should make your decision. Should I retrieve the first ls or should I retrieve the next ls? Clear? And you can ask me that I should retrieve the second ls. And this is complicated than how easy it sounds. See, first ls index can be retrieved using students dot find, right? Find ls. You will get the first ls index. But what if you want to find the second ls index? Second ls is equal to same students dot find. However, here you should mention the starting position. You should not start searching from zeroth position, but you should start searching from everything after the first ls. Print first ls, second ls. Okay. I matched the same number, right? Give me a minute. First ls plus 1. See? So if you find or index will only help you understand whether something exists in a substring exists in another string or not. If you really need, if you are in a situation where you already know that multiple values exist and you want to retrieve the first one or second one or third one or fourth one, see, I think it doesn't make any sense. And there is no real world use like I want to only fetch the, yeah, I think yes, there is a use case. What if you wanted to know the index of the second or the fourth ls when there are multiple substrings in another? In such case, what you should do is you should proceed sequentially. You should first find the index of the find will return the first index, right? First occurrence index. You need to capture that into a variable, and then the second occurrence index should be used using find, but the starting position should be shifted not from zero, but the first occurrence plus one. So it knows that I should start searching here from here and not from the start searching from, let's say I wrote one, right? Start searching from here and not from here, because if you start again from zero you will get this one, right? So you should at least start anywhere in here. You can add plus one. Ideally, we should add plus n plus length ls. See, I found out that first ls started from 0. So my next search should start from e, right? It should not start from a. So when I started searching from e, I got a, and it is at position 11. Is this clear? I think
Yes.
this went over the heads of some of you guys. This is a pretty advanced situation. Just know that find and index are used to determine whether a substring exists in another string or not. If you want to know the number of times, you can use count. And upper, lower, strip, and everything is easy to understand too. Finally, ignore this. You can go over this if you understand it. Okay. If you don't get it, leave it. Now, this is important. What if I wanted to convert? I have a string and I want to convert it to a list of characters. All you have to do is wrap the keyword list around it. Here, ABCD is a string, right? But I wanted to quickly create a list from it. Int list, type list. If you see, I am actually avoiding trying to use the list as my variable name because, as explained earlier, list is a keyword, right? So I should not use it as my variable name. So you will find me using something like list, tup, dict, and something like that instead of the actual value, actual complete names. See here, this is just a string. I quickly wanted to convert it into a list of characters. All I have to do is wrap list around it. And I also tried to confirm the type using the type. I printed the value and also confirm type using type keyword. Good. Now, okay, I failed to explain split, right? Split. What if you have a string and want to split it into multiple smaller strings based on a character? Let's say, yeah, students will work just fine. I created students above, right? Actually, let's say a junior dev accidentally recorded the names of students as a string instead of strings separated by commas rather than a list of names. And when you are working with that project, you are faced with a situation where you have a string containing all usernames, but the name is separated by a single space, and you want to convert it into a list of strings. This is a real world situation, right? In such cases, what we do is use the split method on the string. As list is nothing but students dot split, and you have to mention on which character should I split. If you don't mention any character, it will split. It will give back a list of characters. Let me try to print it. List. No, I think it will return the. Yeah, if you don't mention any character, it will just return back the original one. Oh, wait. No, it automatically splitted on space. Cool. Good. Looks like if you don't mention any character inside the split, it will automatically split on the blank space. That is the space that we give. If we try to split it on, yeah, you didn't find any. Hmm. See, I tried to split. Wait. Value error. Empty separator. Hmm. Good. Looks like you can't split on an empty separator. Okay. Let me try to split on space. See, it returned an it broke the student is a single big string, right? Here we have spaces in between them, and when I used the split, it broke them down over the empty space and returned a list of strings. Is the split clear? Good. We similarly have something called a join. Join is the opposite of split. It will join a list of strings back into a single list. Sorry, single string. Let me try to print it. Here I have a very big string. I tried to split it over blank spaces and I recorded that value inside a variable. Now what if I wanted to join them together using commas? Here I am just asking Python to please join everything inside S list using comma between them, placing comma between them. See, is the split and join clear? Good. Encode, delimiter, decode, ignore, encode and decode. Finally, operations on strings. Operation is nothing but adding something like how should I put it? Operating is nothing but operating two different data types on each other to derive a new value. But you find operations mostly on we have learned, right? Arithmetic operations, relational, logical, and membership. There are only a few operations that can be directly used on strings apart from relational and logical. The plus and star. This is as clear as it looks. Plus doesn't, it will concatenate two different strings to give back a new string. New. And star is also identical. It will just repeat the same string again. Let's say 4. It will repeat the string 4 times. See, the first one I tried to add ABCD with SDFDF and it returned me back a new concatenated string. I did print it. Then I just multiplied it with 4. What what happened was same string got repeated 4 times. Yeah, okay, I must have missed this. Starts with and ends with all is also very important. Just like the sound, they will find whether a string starts with a value or not. Students dot starts with ls. This will help me find out whether a string is starting with a specific set of characters or not. And the ends with also will behave identical. It will find whether something ends with a set of characters or not. True. Let me print actual student values so you understand. See, here the students contains this string and I tried to check whether the students starts with Alice and it is returning me true because it is true. Now I can also check whether student is ending with ends with Bob. Bob already inside John. I am checking whether students ends with John, but false because students ends with Bob, but I am checking whether it ends with John. These are very useful for framing conditions. Is lower, is upper, is title, just like the sound, it will return true or false whether all characters are lower or all characters are upper, all characters are title, and so on. See, string is actually the data type that has the most number of methods in our Python. You won't find these many even in a list and a tuple too. So take your time. They are very easy to understand. Just go over each method, how it looks, what are its argument, and what it does. And also try to create on some random string and try to implement every method on it so you understand how it actually works. Good. Yeah. For today, we only learned how to create strings, list, and tuples, access data from strings, list, and tuples, slice and override in case of a list, and slicing and overriding will not work in case of string and tuples because they are immutable. And we have gone over methods of the strings, right? Tomorrow, what we will do is go over the methods of list, and some of the methods look exactly the same as list unlike exactly the same as strings, and unlike strings which will return a copy, there are three different types of methods on lists. One will affect the original and return nothing. Few will not affect the original and will return a new value, and some will affect the original and will also return a new value. This might sound scary, but I have cleanly categorized them in my lists notebook. You can go over it, or I will go over them tomorrow. And methods on the tuples are nothing but a subsets of the methods on the list. If list has 10 methods, then 5 of methods will not work on the tuple because it is immutable, and the list of the 5 we will have already covered them. And then we will just go over some edge cases, some special features of strings, lists, and tuples. Clear? Go over the notebooks if possible. Try to implement everything. Does any of you have any doubts? Good.